Okay, I think it was von Clausewitz who said that no battle plan survives the first contact with the enemy. And although I'm among friends here, I think my battle plan didn't really survive the first contact with my friends here, because John already made several of the points that I was trying to, planning on going to make. But I'll just repeat them, first of all, because it would be very silly to say now, okay, I'm already done. And second, because I think they're worth repeating. And of course, I have to say that. I'm going to talk about what it is that we want to reproduce or replicate or whatever. And I think that there are some very important points there. I mean, what most of us here, even though we talk about phenotyping in general, but most of us here are interested in is of course measuring behavior. And if we say measuring behavior, what we actually mean is measuring individual differences in behavior, differences between individual mice, individual humans, or individual plants, if you want to, as one of the deans said this morning. And one of the points that John already made is, so what do we measure? I mean, this is the kind of stuff we do every day, right? We measure learning, anxiety, depression, hyperactivity. No, we don't. What we measure is numbers of responses. How many correct, how many incorrect. If an animal increases the number of correct responses over time, we can say, okay, he's learning. If he doesn't, does that mean he cannot learn? That already starts to become more complicated. The same thing with anxiety. You measure time on an open arm. We cannot measure anxiety. We cannot measure learning. The thing is that learning, anxiety, these are constructs. And we infer them from the data that we have. So we get data, we try to interpret them. And that is not the same thing. And this is just human, and I'm guilty of this as much as anybody else, that we tend to confound measurements with the underlying psychological constructs. I too say, oh, we measured anxiety in these animals, and no, that is wrong. If you start saying that, you're already misleading yourself, and you get into the mindset of thinking that you actually can measure anxiety. I think that in the two different kinds of replication, most of us are concerned with, are we replicating the results that we obtained with a particular strain on a particular test? So one of you does a plus mace test with black 6 mice. I, in my lab, do a plus mace test with black 6 mice, and do we get similar results? There's a different type of replication that we may talk about, and that is, are we replicating the conclusions? Like, okay, I have a mutation in an animal, and the mutant is more anxious than the control. And you do the same experiment, or a similar experiment, and are saying something like that. So that's not the same thing. Replicating results is a practical thing. We've been talking about, okay, standardizing lab environments, standardizing the experimenter. We can fly around lab technicians from one lab to another and standardize that too. It's a very important practical point that you arrive at getting reliable measures even within your own lab, because that might sometimes be difficult too. What I think scientifically is much more interesting is replicating the inferences that we make from the data that we have collected. So conclusions about anxiety, about learning, do we replicate that? And that's not the same thing. And I'll show you an example. So this is an experiment we did years ago where we applied semi-randomly unpredictable chronic mild stress to mice. And so these are different stressors that we use, and some of them are a little bit more less mild than others, but basically it's very simple things. I mean, things that mice don't like. And we do it twice a day. In the weekend, only one thing, because you don't want to spend your whole weekend in the lab. It's very stressful for the experimenter too, because on top of that, it's on different times during the day. So sometimes you do it at 9 a.m. in the morning, one thing, and 2 a.m., 2 p.m. something else, and the other time you do it at 11 a.m. and 5 p.m. or whatever. I mean, always is very variable. So your grad student gets very stressed too, because he should not forget when to do what. But it's mild things. Basically, what happens to the mouse is that something unpleasant, mildly unpleasant, can happen any time during the day, but he never can predict when it's going to happen. And this is supposed to be a model of depression. I mean, if you do this long enough, then the animals will get depressed, which I think you can all relate to. Now, in testing depressive behavior, how do you test for depression in mice? So there are a few tests that are used a lot in pharmaceutical industry and the tests that we do with the mouse mutants that we create or that we get from colleagues and test. So there are two tests that are really used a lot. One is the tail suspension test, and you see that over there. Like most of our behavioral tests, it's a highly sophisticated test. You need a paper clip, you need a piece of scotch to go around the tail, and you need a nail in the wall where you can hang up the mouse. And so this is very, it looks simple. It's not as simple as that. It starts with that. I mean, of course, because you have to make sure that you're not too high at the tip of the tail, because then you would hurt the mouse, and that would bias the kind of test that you're doing. Anyway, so a mouse doesn't like to be hung up by the tail. There's no surprise there. So they will struggle to get out of that. By the way, if you go too low, then they will climb up that tail, and they're fine. So you have to take care of that too. They struggle. At some point, they give up and hang there. Behavioral despair. The measures that you take is the latency to the first bout of immobility and the total amount of time that an animal is immobile during the test. And you take that as an indicator of whether the animal is depressed or not. Another test developed by Porcel, so we call it a Porcel test. Again, a highly sophisticated test. You take a beaker glass, you put water in it, and then you put a mouse in there. And they can't escape. It's the same thing. It's an unpleasant situation. Especially mice hate water. They're not like rats who like water, but mice don't like water. So they will do the same thing. They will struggle. They will try to get out, and at some point they give up and they just float in the water until you pick them out, get them out. You take the very same measures, latency to the first bout of immobility, total time that the animal is immobile. And again, you're measuring behavioral despair, right? I mean, that's what we say. That's what we write in our papers. Actually, John had a very nice way of saying that. It was something like that well, we think might not correspond to the reality of the mouse. I think that's the same thing here. So these are the results that we got for Porcel and tail suspension in males and females of 3 different inbred strains that have been either not stressed or subjected, I think it was 3 weeks of this chronic mild stress procedure. And even just without looking at details, if you compare the two figures, you see that it's not the same thing. If you look at the ANOVA results, I mean, here we have a sex effect, there we don't. There's a strain time sex effect, here we don't. And if you look at the B6 males, if you only had used B6 males, in one test, it's, well, what you would expect. The stressed animals show higher immobility times, so they're depressed, right? That's what we do. But if you do this in a Porcel test, it's the other way. No, wait a second. I mean, is that which one? No, yeah. Oh no. I was yeah. So if you do that in the Porcel test, it's actually the other way around. So by stressing them, they get less depressed. I don't really know what's going on here, but one thing seems to me be clear is that the two tests apparently don't measure the same thing. Even though you have the same behavioral measure, you have the same behavioral construct behind it, That's what we think. That's the construct we thought up, but the mice apparently disagree. I think that one of the problems that we have is that when we say results don't replicate from lab to lab, it's not just that if you do a plasmase test and I do a plasmase test that we get different results. I think that very often somebody publishes that a certain mutant is more susceptible to be depressed than controls, and I published that the opposite, but it's because we use different tests. And I think that that is a point that is really neglected a lot. And I think that we actually need to validate our behavioral tests much more than has been done. And we need not just to validate them, we need to cross-validate them. Now, I have a few examples. How do you do that? How can you validate or cross-validate these tests so you actually can say what's going on? Okay, this is a Morris maze. We all know the Morris maze. It's not a maze, of course. I call it a water escape test because there's no maze. It's just a pool. This is a protocol. This is data from Hans-Peter Lipp and David Wolfe. And that protocol was that they had 6 trials a day for 3 days. And then they take the platform and put it in the opposite quadrant. So you get what they call reversal learning and do the same thing for 2 days. And this is a typical example. What you see is that after a while, the mouse knows where the platform is. So he has learned something. I actually remember reading in Science at some point that this is the gold standard of learning, the Morris Water Maze test. Okay, well, what did Wolfe and Lipp do? They actually measured a lot of different variables in this test. I think that everybody by now knows that just measuring escape latency in this test is not enough. I mean, that will not necessarily tell you whether the animals have learned or not. Some animals will actually increase their escape latency, whereas at the same time, they, when you look at traces, the distance they swim, they diminish the swim distance. So they know where it is, but they successively swim slower over trials. Why they do that, they didn't tell me. Now, if you have a lot of variables, that's what Wolfe and Lipp did. They took a lot of different variables in this water maze and then did a factor analysis, which I guess most of you will be at least somewhat familiar with. And when you do a factor analysis, what you then see is that pigmotaxis, the tendency to stay near the wall, explains about half of all the variance between animals that you did. And this is based on something like 1,200 animals. So it's a decent sample size, I would say. The second factor, passivity, that's the tendency of some animals just to float in the water. Belt seals are really well known for that. Being passive is another 20% of the variance. So now we have already explained 70% of the variance. And then there's a whopping 13% that has actually something to do with memory. So I'm not saying that this test is a bad test. I'm saying that it might not be the gold standard for learning that we take it for. And not only that, but if you find a difference between 2 strains or mutants and wild types or whatever, that it might not necessarily be the learning difference that we think it indicates, but it might be perhaps a difference in the tendency to show pigmotaxis or a difference in the tendency to be floating in the water. Understanding what's going on in a behavioral test is very important. And it's nuts that we have to say this, but actually, this is something you only see when you actually look at your animals. So when we talk about automatizing tests, it's very nice for standardized because then everything gets done in exactly the same way. But if you don't look at your animals, you will not realize what they are actually doing. Here, they looked in detail at the animals, looked at what kind of variables can we measure, and what does it mean. Another test is a test I personally use much more, is the radial maze test. And you can buy I just randomly picked these off the internet. You can buy mazes that are pre-made, so you just buy them and you use them. And this is also supposed to be a test of spatial learning, right? Now look at the mazes that you can buy. How is a mouse going to orient themselves in space in a thing like this? With opaque walls, they're in the center. I mean, they can't, how can they orient? They can't. This is not a spatial learning test. Well, at least they're, even though they can't see much from the environment, they can go just one arm to the next and do it that way. But is that spatial learning? Here, this is another one. Okay, so at least there, they can see the environment. It's an elevated maze. What was the anxiety test again that most of us use to test anxiety? A plus maze. So meaning that if you have two groups of animals that differ in anxiety, you might really expect to find a difference in performance on this maze, which you might then interpret as a difference in learning behavior, but it isn't. It's a difference in anxiety. And that's another point that John made, that there are very few tests that really just plug into one behavioral domain. A test like this, anxiety plays a role. I really would not lose any bet on that, I guess. This is how we do it in my lab. We have a plexiglass maze so that the animals can look outside. It's placed on the floor, so there's no elevation, there's no anxiety. That's why it's, of course, covered. You can't see that, but there's a plexiglass cover on there so that the mouse doesn't escape into the lab. We put visual cues very close to the maze because we want this to be a test of spatial orientation, not a test of visual acuity. And some of the animals we use, we know they have bad vision. Albino mice, they don't see very well. They're not blind perhaps, but they don't see very well. So that's why we put them. We hide the food behind a little barrier so the mouse can find it. Actually, that was a piece of food we used just for the picture so that you really can see it very well. But usually we take much smaller ones because otherwise the animal gets satiated before he has eaten all the eight food rewards. Okay, so now cross-validation. Cross-validation would be when you want to compare two different tests and see whether they measure the same thing. And that is actually, I think, a very important thing, like the Purcell test and the stale suspension test that I showed you. Are they measuring the same thing or not? And if they're not measuring the same thing, what's the difference? The problem in behavior, of course, actually not only behavior, but physiology often too, is that you cannot retest the same individual because a repeated measure, just by the fact that you have done the measure already once before, may influence how the animal behaves or reacts on the second test. Open field, I mean, you put an animal in the open field, if you then do it in a different open field even, whatever, I mean, the behavior will differ because of the previous test exposure. A solution to that, I don't think I have to explain that too much here, is that you use what you can call a replicated individual, inbred strains. So here's just one example of that that we did in my lab, where we took two different radial maze tests, and the details are not even that important, but here we baited 4 out of 8 arms, here all 8 arms were baited. And you look at the correlation you get between the different inbred strains, and you see that there's a pretty good correlation. Although we might want to look at this animal, why it's, that strain, why it's outlying there so much. But you get a pretty good correlation. So here you could think that those two tests that you're doing there, the two different tests, are basically tapping more or less in the same kind of behavioral domain that you want to test. And unfortunately, that kind of things have not been done too much with different behavioral tests that we are using. I'm not going to explain all this in detail. What we have here is the results of a lot of different tests, and we did, and they were all tests that you could use as spatial learning tests. We did a factor analysis of it, and we got 3 different factors, meaning that we basically are tapping into 3 different behavioral domains here. And this is all radial maze tests, and depending on the protocol and the configuration of the maze, you get different results. And so if we get back to the question of what it is that we measure, we have to say that most of the time we have no clue. And that's not just, we're talking mainly animals here. I think it's the same thing if you talk about like psychiatry. I heard a talk by what's his name, the director of NIMH, blanking. Tom Insel, thank you. A talk by Tom Insel a few years ago, and he said, okay, so suppose you have chest pain. You have pain here. You go to a doctor and you say, doctor, I have chest pain. And he examines you, and his diagnosis is, well, you're suffering from chest pain. That's not really very helpful, because it could be your heart that's doing something. It could be your lung that is posing a problem, or just perhaps you tore a muscle or something like that. But in psychiatry, that's what we do. We look at symptoms, and, well, we see delusions. We say, well, this person's schizophrenic, and they talk to you like that, and they're socially awkward and such. Oh, that must be autism. And whether that is one disorder and different disorders and things like that, we don't know, because we don't really have defined and validated those concepts as much as they should be. So I think that the problem in behavioral phenotyping in mice is not really that different of behavioral phenotyping in humans. And by the way, I mean, John made a remark that it was easier in humans, kind of, because you could give them paper and pencil and ask them questions. That of course hinges on the assumption that they are going to tell you the truth. So I think it's what we need to do is to validate and cross-validate our tests. We need to start understanding our animals. Anxiety, how often already this morning have we mentioned the word anxiety? If you go to DSM-5, how many anxiety disorders are there that are supposedly different anxiety disorders in humans? I think like 10 or 12 or something like that. And what do we do with our mice? We talk about high and low anxiety. If we really go into it, you might distinguish between state and trait anxiety. But that's about it. 2 forms of anxiety. We don't talk about 10 different forms of anxiety. So our understanding of what the behavior is doing, what the behavior means, I think is severely lacking. In order to get to good validation and cross-validation, we need to measure multiple variables, not just put an animal in a Morris test and measure escape latency. It's not going to help you, not going to bring you that much further. If you have only one variable, it's very difficult to understand what actually is going on. Okay, these were the people that collected the data that I showed you, not that much data. And I'm ready for any discussion.